Good morning, I'm Mirko Orsini. During my PhD, the research activity was focused on query management in data integration system. In particular, it was focused on the MOMIS data integration system. My advisor is Professor Domenico Beneventano, and my co-advisor is Professor Isabel Cruz. First of all, I want to introduce the field of semantic integration of heterogeneous data. Data integration provides a global virtual view, a global schema of sources that is a conceptualization and ontology describing a set of distributed and heterogeneous data sources. So if we have a set of heterogeneous data sources as a DBEM file, XML file, the purpose is to describe the sources with the local schema and then integrate the local schemas in a global schema and to generate the mapping between the global schema and the local schemas. Then the user can pose a query and can receive a unique answer, a unified answer, in a transparent way from the involved sources. My research activities was focused on the MOMIS system, that is a mediator environment for multiple information sources, that is a framework to perform information extraction and integration of heterogeneous data sources, structured and semi-structured data sources. The system is developed by the database research group of the University of Modena Reggio Emilia, and the system performs semantic integration of information through a common data model, ODL-i3, that is an extension of the ODMG data model. And the local schemas of the sources are available, so the system performs source wrapping. And in the MOMIS system, we have a set of techniques to construct the global virtual schema, like the local schema notation with respect to common lexical ontology, and the semi-automatic generation of relationship among the local schemas, clustering techniques, and semi-automatic generation of the mappings between the global schema and the local schemata, what we call mapping table, and a semi-automatic annotation of the global schema with respect to the common lexical ontology. So the problem is, when we have generated the global schema, how to answer the query expressed on the global schema. In a virtual data integration system, the data resides at the data sources, then the query processing is based on query writing techniques. A global query is then written as an equivalent set of local queries that are executed on the data sources. Most of the systems follow a GAV approach in practice. Most of the implemented data integration system. And with the globalist view approach, a GAV approach, the query writing is performed by the unfolding, and by expanding a global query expressed on a global class, C, according to the view associated to C. When the view is defined with an outer join merge operator, the query writing performs the fusion, the object identification, and the conflict resolution of the local answer into the global answer. During this 3 years of my PhD, I focused on different topics all related to query management in the data integration system. So the first is information integration. One of the activities was the analysis of the current languages for the description of ontologies, and a language and a methodology for the domain ontology specification was proposed, and the domain ontologies have been developed by using the MOMIS system in different research projects as Wisdom, STIL, and App4B project. Another activity was the analysis and comparison between commercial and research data integration system, and the study of benchmark, the Thalia benchmark, for data integration problems that is focused on the syntactic and semantic heterogeneities. So the MOMIS system was extended to support all the queries of the Thalia benchmark, by extending and combining the declarative translation function and without any overhead of new code. This is a remarkable result since no system, no data integration system, has provided a complete answer to the benchmark. And the result was published in an international conference. Other research activities was focused on the object fusion problem in distributed query processing. So the first activity was focused on the definition of the relevant values that are a new kind of metadata that offers a synthesized view of the values of an attribute. The relevant values are exploited by the users when creating or refining a search query in a knowledge base. The technique of extracting the relevant values is automatic, independent from the attribute domain, and based on data mining and clustering techniques, and emerging semantics from data values. The effectiveness of relevant values when searching a knowledge base was proved by the experiment on the relevant prototype that was implemented. And a new prototype was implemented, the relevant news, that is a newsfeed reader that is able to group similar news by means of data mining and clustering techniques, applied to the feed titles of the news. And relevant news identifies and groups set of related news on the basis of syntactic and lexical similarity. And the result of these activities was published in a journal and an international conference and in a national conference. Another activities was focused on the conflict resolution problem in query rewriting and the execution over a data integration system. The fusions of data coming from different sources have to take into account the problem of inconsistent information. A method to solve these data conflicts on the basis of appropriate measures was developed. This method dynamically performs conflict resolution based on this metadata, and that are provided by the underlying data model. Another activity was focused on the access control in data integration system. Data integration system integrate data from different sources, data integration, data interpretation system, and enabling the communication and exchange of the data between these different organizations. And depending on several factors such as the task, the participants, and data sensitivity, the access to integrated data needs to be controlled and enforced by security policies. During these research activities, a method for mapping security level among the components of a distributed system has been developed. And the principle of local autonomy is respected in this model, such that the local security policies continue to be valid, preserving data confidentiality and availability. And another research activity was focused on the developing of a security framework for collaborative application that relies on the role-based access control model, RBAC model. And this security framework has been proposed in an international conference. Such a security in such a context, the user are not previously identified, so the action that the user can perform into the system, into the environment, are dynamically determined based on their own attribute values and on the attribute values of that are associated with the resources. So the roles are assigned on the basis of the attribute values. And a prototype has been developed by exploring the capabilities of semantic web technologies, and in particular of OWL 1.1, to model both the security framework and the domain of interest, and to perform several types of reasoning. So I want to focus this talk on one of the most recent activities I did during this last year. That is the developing of a second mediator for integrating multiple level access control policies. And I did this work when I was at the head of this lab at the University of Illinois Chicago, that is led by Professor Isabel Cruz. So, in this context, the data integration model is, we have several XML data sources. So we have XML instances and the local XML schemas. And through the data integration system, we generated a local RDF schema. So the language is the RDF, the common language for integrating the sources. And the system generates a global RDF schema. So we have the mapping between local schema and global RDF schema. So a user can then pose a global query on the RDF schema. The query is translated into is written into a set of queries to the local RDF schemas, and then executed on the local XML sources. The access control model we consider is a mandatory access control model in each local organization. So the data are classified in different security levels, and the security levels form a partially ordered set. In this example, we have two organizations, an hospital and health insurance. Here we have the security levels that are organized in partially ordered set. And the users are assigned the security clearances that follows the security levels. So a user can access only the data that are classified at a security level dominated by the user security clearance. So for example, a user that is classified on a medical security level can access to the medical, administrative and public levels. The problem is that of integrate the local organization model into a global model. The assumption, the requirements of the system are the autonomy. The local security policies must not be affected by the security policy of the global level. The confidentiality. So given a security clearance, if a schema element is not accessible locally before integration, then it must not be accessible also after integration. And the availability. So given a security clearance, if a local schema element is accessible before integration, then it must continue to be accessible also after integration. The example is that of a medical domain, where we have two local XML sources, an hospital local XML schema and a health insurance local XML schema that are decent example that are these representation are the XML3. So we have in this case, like in the most of the cases, semantic heterogeneities between terms. So for example, in this example, patient and customer refer to the same thing, and credit card and credit card number refer to the same things, the same concept. And we have structural heterogeneities. For example, in this first, the patient is contained in hospital, like in the second, the hospital is contained in customer. On the XML schema, we define a set of security levels that are applied to all the instances of the associated XML schema elements. So we defined the security specification, a pair VS, where V is the XML schema tree node and S is the security level. So for example, if we have this kind of partial order for the security levels, and that is the schema tree with the associated security levels. So for example, the hospital element is public and the patient is administrative. The first step of the integration is from the local XML schemas to local RDF schemas. The simple XML schema elements and attributes are transformed into RDF properties, and the complex XML schema elements are transformed into RDF classes. So here we have, for example, the classes hospital and patient, and the RDF vocabulary is extended with the property RDFX contained property to keep track of the containment of the complex elements in the XML schemas. And we extended the security object model developed by Farkas and other, where a security object is a pair TS, where T is RDFS triple and S is a security level. So for example, we can have the triple budget RDF type RDF property at level administrative, and so every object in the RDF schema is associated with a security level. Every node and every edge in the RDFS graph. So the second step is this translation of security level from XML schema to RDF schema elements. And a subject triples is contain only one element derived from the XML schema. So the triple are represented by graph nodes, and the security level of each triple is the same that of the schema element. The complex case is when we have subject objects triples that contains two elements derived from the XML schema. So the triples express a relation between two concepts. They are represented by edge, and each triple has a security level equal to the least upper bound of the two elements. So the least upper bound is the smallest of the upper bound. This kind of property assures that each element is accessed only by the users that can have access also before integration. The second step is the translation from local RDF schemas into a global RDF schema. So this integration is made merging or copying class and entities from the local schema and to the global schema, and we have a one-hand relationship between an entity at global level and the local sources. So here we have the local XML schema, the translation into a local RDF schema, and the global RDF schema. So for example, patient and customer are integrated into the global RDF element patient, credit card number in credit card, and social security number in the property social security number. So the problem is to create the global order of security level. Every local source has its own partial order of security levels, and the different partial order must be merged together in a global partial order. But this kind of merge should introduce no cycles, stated by Dawson and other in 2000. So we define a function theta that maps a set of local security levels, Li, to a set of global security levels. So, in this case, we have the local security partial order, and that is the global security order. So the global partial order is a directed cyclic graph and is applied to the global RDF schema. The problem is that of assignment of security level to the global schema. A global triple is the result of merging different equivalent local triples. And each equivalent local triple has a local security level which is mapped to a global security level. And the problem is which security level must be chosen for the triple at the global schema. Since the ontology serves a mediator, a least restrictive approach must be followed in the assignment of security levels to the triple of the global schema. So, here we can see two local security level, administrative, that are mapped to two different global security level, administrative and S-administrative. So the problem is to decide which of this global security level have to be chosen for the credit card. And following the least restricted approach, the model chooses the administrative level. So the mapping of the security levels induce one or more subgraph S on the global partial order. For example, this is the subgraph, administrative and S-administrative. Following the least restrictive approach, then the global triple is assigned to the security level that belong to the source of S. That is, the source of S is the set of nodes without incoming edge. So, in this work, I present an approach for translating security levels from XML schema to RDF schema, such that we guarantee the autonomy, the local organization do not change their security levels, and the local security level remain valid in the local sources. We guarantee the availability. The global security levels are the least restrictive ones, therefore availability of the data at the local sources is preserved, and confidentiality. The confidentiality follows from autonomy and from choosing the least upper bound of two security levels in the first step of the data integration process. A future work will be the integration of the approach into the monitoring system and to perform experiments. These are the list of the publication on international conference and in journal and national conferences, and some technical reports. That's all. Thank you for the attention.